but it looks like there was no microphone.
No. You'll just see the screen.
Yeah.
No voice over.
Yeah, I'll probably edit and do a voiceover. So, check this. The ball is thrown vertically downward. So since we know it's not dropped where the velocity initial would be 0, then we know the velocity initial would be the magnitude of the velocity with which it's thrown downwards. And to answer 3.1, then that velocity initial is 10 meters per second. And how do we know that? We read it off the graph as this point here. So that's VI. Okay. Then the second part of the question is to
So I don't think we're on the same page, are we?
is to give a reason why all the parts have the same. Which Jamboard did I pick now? Okay, start from scratch. Because this is the one
Can't
I'm
you
going
copy
to.
and paste from like the other page?
Doesn't look like I can. I would have done that if I had thingy. So anyway, standard 10. Grade 12 paper. Feb 2018. Paper 1. And we're doing question 3. Right? And in our graph here, question 3, we have on the vertical axis the velocity and on the horizontal axis the time, right? The time is the measure of how long this whole activity takes place. And we're given a few stats. The vertical axis is the velocity of the motion of the object that we're looking at. Now, when the motion of this object starts, it starts at 10 meters per second and it increases to a maximum velocity of 29.6 meters per second. Then at a certain part, at 2 seconds, it seems to have changed direction, or rather the velocity seems to have changed direction, and it increases from a certain value to another value. And then again, the velocity changes. Let me just... because I see I did an error there. Alright, cool. Alright, so in the first instance, the ball, this is the motion when the ball drops, or rather has been thrown, right to the point where it hits the floor. Comes into contact for a couple of or fraction of a second with the floor, and then bounces up. This is its velocity bouncing up, so we can take upwards as positive. So that's the velocity bouncing up. Then at velocity equals 0, that's when we have maximum velocity, where it is not, is admit. Alright, cool. So, yeah, so we're doing a bit of revision, so you might get a bit more out of this problem, because we're doing it again now. I'm saying we're repeating this question. Okay, no problem. Yeah. Right, so I just want us to describe the motion, right? So before you answer the question. So ball is being dropped. That's the velocity at which it's being dropped. That's the point where it hits the floor the first time. That's how long it comes into contact with the floor. Just get jammed there. That's how long it comes in contact with the floor. From 2 seconds to 2.2 seconds. Then it moves up again, changes direction, then moves down, hits the floor again. So I'll just put like a little explosive icon there and another explosive icon there to show that it's hit the floor. So it's traveling down, hits the floor, comes into contact for 0.2 seconds, travels up, changes direction, travels down, hits the floor, comes into contact for a certain amount of time, then again travels up, and then we don't know what else happens there. And if we want to illustrate this, let's assume there's our building there. I'll just rub it out there just to show that we don't know how tall the building is. But so-and-so has thrown the ball down, and that ball goes, bounces there, then travels up, changes direction, bounces again, and then, right. So we don't know how long this goes on for, but what we know about the motion of bouncing is that initially the ball is at a certain height, but after its first bounce the height decreases, and after the next bounce the height is much less than it was the first time when it was thrown. So the way this graph looks pretty much represents the way this ball bounces.
Okay, so it has, can you say it has 2 maximum points?
Maybe 3 if you include the first point. Maybe 3 if you include the first point.
So what I feel is that when at V is equals to 0, we can tell we can see what that's our
Maximum height. Yes. And so to answer the questions, 3.1 is the speed at which the ball is thrown, which we read off the graph. It's 10 meters per second. But now the convention is that upwards is positive. Why is upwards positive? Because here the motion of velocity, the magnitude of velocity that is increasing, shows in the graph itself because it slopes up. So it shows that
it's an increasing function.
So it shows that as the I'm wrong to say upwards is positive. It shows that as the ball drops, we regard the motion as positive.
Okay.
Yes. So as the ball drops, down is positive, right? So we write there.
If up was positive, then we would have negative values for velocity.
Yes, if up was positive, we would have negative values for velocity or motion going down. That's correct. So 3.2, all parts of the graph have the same gradient. What's the reason for this?
What's the reason?
It's because even if it's dropped, the ball is subjected to acceleration due to gravity, and the only time when a certain velocity was applied was at the beginning. So for the rest of the motion, the ball is just subjected to acceleration due to gravity. So even though it is accelerating at a certain rate towards the center of the earth, the velocity increases at the same rate because of that constant acceleration. So the acceleration due to gravity is constant, therefore uniformly increasing velocity. Therefore, uniformly increasing velocity. So that's a big reason why all the parts of the graph have the same gradient. Now to calculate the height from which the ball is thrown, we have the initial velocity, which is 10 meters per second. We have acceleration due to gravity, which is 9.8 meters per second squared. We have the time it takes to go from the top of the building to the floor where it starts bouncing. And how do we know that time? It's this time frame here. Right? That's how we know. Right. And then I guess that's 2 seconds. Then we can go to our formulae that have height or change in displacement, etc. We could probably look at which one?
This one.
Yeah, we can use this one or that one or that one. So we'll just use, what is it? Change in displacement.
Change in displacement is equals to initial velocity.
So change in displacement equals initial velocity
Times change in time.
Times change in time plus a half times acceleration due to gravity times the time squared. Okay? And this change in displacement would be y minus y initial, and this equals vi delta t plus half gt squared, and y equals yi plus vi delta t plus a half gt squared. So now, Joy, I just want you to notice something, because we discussed this when I was doing the same problem with Nogushokore. Delta y can be thought of as a height, a certain height minus initial height of the building, right? So if we think of moving up the building from the floor all the way to the top of the building, then if we have y there, we have yi there.
Why I there at the bottom?
Oh, because it's the initial height.
It starts at the bottom going up.
And then going up, yeah. So what that then leaves us with is, we don't know this height, but we know that that is 0. We know that the velocity initial is 10. We know that the change in time is 2 seconds. And we've got a half times 9.8 times 2 to power 2. And when you punch that into our calculator, it gives us an amount of 30 something. 30 something.
I get 39.6.
That is the correct answer. Now we can remember this one, right? All right. So it's 39.6.
I was just double checking my answer because I took a shortcut.
39.6. Now I drew a smile instead of a comma there.
It has 2 eyes.
Yes, it's a smiley.
How did you get?
How did I get one?
How did you get those 2 dots to be like so tiny?
Because with my finger the pressure is different.
Oh.
Yeah. With my finger the pressure is different than with the pen. At least here I can simulate actually writing, and the thickness can increase and decrease accordingly. So the second part, the time t shown on the graph, which is right at the end there. So 3.3.2. And how many marks is it? 4 marks. 4 marks.
Max.
4 marks. Let's see, we've got the velocity at which it travels up. We've got the final velocity. we've got the change in time, we've got acceleration due to gravity. So if we've got velocity initial, which is 25 meters per second. We've got velocity final, which is 0 meters.
-25. Oh, you don't want to write magnitude.
Oh yeah, it's -25 because it's traveling up. You're correct. It's traveling up from the floor. So, and up is negative, yeah. So we've got the final velocity 0. We've got acceleration due to gravity as 9.8 meters per second squared, positive. And we've got change in time is t minus 8 seconds. So I'm sure there's a formula there that has the two velocities and acceleration. Is it v equals v plus at?
It's v final is equals to v initial plus acceleration due to gravity multiplied by change in time.
All right, so
Acceleration due to gravity.
the constant g is acceleration due to gravity.
Huh?
Gravity or change in time?
Gravity.
Like delta T?
Or
Yeah.
delta t is change in time, yes, you're correct.
Yeah, so is it not velocity final equals to velocity initial?
Yes.
Acceleration?
Mm.
I don't know.
Yeah.
Yes, that's the correct one. So we're gonna substitute. We have the value of Vf is 0 and Vi is -25. Acceleration due to gravity is 9.8 and change in time is t minus 8. Additive inverses, that gives 25 equals 9.8 t minus I guess 9.8 times -8. It's how much?
Minus 78.4.
Minus 78.4 times +1, yeah. Okay, so minus 78.4, 9.8 t, 25. Then we take the 78.4 using additive inverses to the other side. Then it becomes 100 and how much? So 25 plus that would be 100 plus, so 103.4 equals 9.8 t. Therefore t is 103.4. That sounds like the frequency of a radio station.
Yeah, I think it's Energy FM.
So what's 103.4 divided by 9.8?
10.55.
10.55 seconds. So that means at time t, our time should be 10.55 seconds. I just want to check if that's the correct one, because the answers feel so different from what we did.
Really?
Yeah.
It's the correct one. Never doubt it.
No, Butle, how did we get it the other time? We didn't get it this way, ne?
We didn't even get there.
We couldn't get here.
As figure gala.
Oh, okay. Then it's good that we're carrying on from here then.
Yeah.
Oh.
Yeah, it's good that we're carrying on from there. So we get 10.55 seconds. So on our graph, we know that this event at time t happens at 10.55 seconds. Alright. So just gonna go back to the first slide in page 1. So initially, our ball is traveling down. As you can see, the blue arrow
Point on your.
on my thing with the laser.
Yes.
Ball is traveling down as the blue arrow shows, and that's that motion there, right? This 0.2 seconds here is how long the ball is in contact with the floor. Then after bouncing on the recoil, it travels up between 2.2 seconds and 4.955. And that's that motion here. Now after changing direction up here, it travels down, and that's this part of the motion up to here, where it stays in contact with the ground for some time, and then travels up again to there. And at t equals 10.55 seconds, that's when it's on top again, but this time at a lesser height than initially when it was starting to drop. Okay, so yeah, 3.4, we'll have the time that the ball is in contact with the ground in the first bounce is 0.2 seconds. And we can read that off the graph as this point here, this space there. 2, 3. All right, and then what was that, Nobuke?
Oh, sorry.
Oh, okay. I thought you were saying something. Oh, okay. The time at which the ball reaches its maximum height after the first bounce. Again, we're gonna read that off the graph, right? The time at which the ball reaches its maximum height after the first bounce. So this is the first bounce. This is the second bounce. So the second bounce is after 4.99955 seconds, and where the first bounce, the maximum height is reached, is here at 4.955 seconds. All right. So at t equals 4.955 seconds is the point of maximum height after first bounce. Maximum height after first bounce. All right. Now 3.4.3, we're asked to find the value of x, and from the graph, the value of x is this velocity here. Now we can see, even from the information that we're given on the graph, right, that x is a little bit, I guess, ignoring the negative side, x would be bigger than 25. But at the same time, since this is a bouncing effect, the velocity at which it springs up shouldn't be as much as the velocity at which it hit the floor. Should be a little bit less. But most definitely it should be above 25, because that's at the second bounce. So those velocities are different. So this one should be more than that one, but it shouldn't be more than that one. So we know we are working within a limit of 29.6 and 25 meters per second for the velocity. So velocity should be between 29.6 and 25. That's at least the idea that we have, right? So I'll just draw a bulb there to show that it's an idea. It's just the idea that we have. Now, we want to find that velocity, and for x, we know that if we have a velocity of 0 there and a time there, and it's also subjected to gravity or acceleration due to gravity, we could maybe say v final at 4.955 seconds is 0, and it also equals velocity at x, so I'll just put an x there, plus acceleration due to gravity times change in time. Yes, so 0 equals the velocity at x plus 9.8, and the time difference between 4.955 and 2.2 is the time difference.
I get.
Eh?
Yeah. How do you?
Okay, let's say Fn. Say that again.
I'm saying, was how long from point of least to maximum height? Tell me what answers and please.
So first one, eh?
I think it's number 2.
Oh, number 3.3.1, it was 39.6 meters.
Well,
But we did do this.
yes, but I'm looking at the answers. That's why.
Okay, you can hop on to scroll to page 2 of our Jamboard.
So I want to check on
Yes.
that other Jamboard and see the answer that you
I
get.
see it.
You see it? Didn't we do it like this? Because remember the delta y, we said it's a certain y which represents the height of the building, and yi would be the initial height from which the ball is dropped. King, if you start counting the height from the floor, then that height going up. So it will be 0 there, and whatever the height there. And then that equals, so it becomes y minus y1 equals v times delta t plus half gt squared. And the delta y is simply y equals the first y plus vt plus half gt squared. Remember that one? Can you see it on page 2 of our Jamboard?
Yes.
All right.
So why don't you check the answer that you guys got?
In the other Jamboard.
That's fine. Oh.
We also got 39.6. Oh yeah, actually, I'm actually even incorrect in this one, because the correct rationale is y minus y1, right? So even if y initial is the 39.6, it's fine, then y final would be 0. So it would be y final, which is 0, equals y initial, which is 39.6, plus Ntrilani. So eventually you get negative yi equals 39.6, so yi is 39.6, but since up is positive and we're going in that direction, then the signs match, yeah. So we did get the same answer on page 3 of the Jamboard from during the week.
Wasn't she talking about this answer?
Which one? Yeah.
That answer.
I think,
her
yeah,
answer
that's
is
the one.
different.
No, it's because the first time when we calculated the other t, we got 2.55 seconds. So we needed to add it to the 8 seconds to get what time will be at t. And then the second time, 0.2 seconds, which is there. And then 4.955 seconds is there. Then, yeah, here we're just going to have to find delta t. And then, because we're just here right now.
So we did it last time. Okay.
But did you get it from the last Jamboard we had?
I have both Jamboards open and then I'm just
It's the same answers, ne? Okay, cool. So the velocity at x would be negative 9.8 times, I guess this is 2.755, which is how much? 27.391?
Yeah.
27.391 meters per second. So now, remember we said our velocity should be somewhere between 29.6 and 25, give or take. And we got an answer that more or less speaks to that. And we can check even on our graph. Definitely that should be the correct answer because 27.391 isn't greater than 29.6 because that's the maximum velocity reached there. And it should be less than, like, it's the velocity that was reached as the ball hit the ground. And it should be less than the velocity traveling up, going back to the second bounce. So this here, negative 27.391. Did we get the same answer in the first jam? I just want to see. But I know it was 27 or 26 or something like that. Because it looks like here we got 26.999. But let's just see the answer. Okay, so the answer must include a negative. Why do we get 27 point? Because last we got 26.999, negative 26.999. Say 9.8 times 2.755.
Get 27.
391. It's 955, not 995.
Yeah, 27.
So 27 exactly, eh?
Yeah.
Alright, so
26.9999.
yeah, I remember that's what we got. 26.99999. Negative 26.999. So let's say negative 27 meters per second. Alright. So we pretty much got that one, the gist of that one. And then we have to describe whether or not the collision is elastic or inelastic. So Joy, what do you think?
When the collision is elastic, energy is conserved.
And momentum.
Energy and momentum are both conserved. And
then when it's inelastic?
It's momentum and energy are conserved.
No. Momentum is conserved in both cases. So momentum is conserved for both an elastic and an inelastic collision. But the kinetic energy for an elastic collision is conserved, whereas the kinetic energy for an inelastic collision is not conserved. Yes. Alright, so looking at the graph that we just discussed now, and I liked Nobusle's answer in the thing. I just want to hear your thoughts on this one, Joy.
Okay.
So looking at the graph that we're solving for, would you say that this collision, the bouncing, is elastic or inelastic?
I think it's elastic.
Elastic. Why?
Because energy is lost through the sound of the bouncing, like the pose.
Wait, but if then that's the case, if it's elastic, remember the velocity would be the same throughout, yes. Because there's no change of the kinetic energy from one form to the other.
Okay. Inelastic then.
So it's inelastic, yes. So the kinetic energy is inelastic. And the reason is, why? Because the speeds at which the ball strikes and leaves the ground are not the same. So the kinetic energies are not the same. velocity for hitting and leaving the ground are different. Therefore, kinetic energies are different. All right. All right. So that's one type of problem with kinetic energy. So yeah, but Nobush, I think with one dimension motion, a sharp must not right. Eh? You'll see in the exam. Alright, that's fine.
And I can't see the exam.
Pela Joe is writing in a month's time, so.
Yes, it's chemistry.
Yes, it's chemistry, girls. Chemistry. So we're gonna do organic chemistry. And the summary is so long, eh? The summary is too long. But with it, I think we should just jump straight. It's paper 2, ne? I think we should just jump straight into the exam and start answering some exam questions. And then we're gonna go into the
I think Nobutle is a fan of chemistry.
oh no, Butle is a G of science, eh? Butle loves science.
No. I enjoy science, but I don't use science. So,
Nah, we also enjoyed science more than math, eh?
I don't know who he is, so.
No, I'm saying me and me and my other personalities.
Yeah, you and other. I prefer mathematics and maybe chemistry too. Like physics, I prefer chemistry more than mechanics.
Ah,
Yeah.
okay. I like them both, but I prefer mechanics more. It's more
Practical.
applicable to a lot more things that you can see and touch and yeah. So yeah, multiple choice. Right. So there's alkanes, alkenes, and alkynes.
Yes,
Right.
alkynes are the ones that have triple bonds. Alkenes are double bonds, and alkanes don't have any form of bond.
All right. Cool. So Nobutle. So we're gonna run through this one like I don't know how, but just
Superman.
yeah, like you know when you're chasing a truck and then you lenamela stuff. What do you call it? Yeah, we're gonna do this with this one, right? So there's 3 types of things. There's alkanes, alkenes, alkynes, and then I think there's also aldehydes, right?
Yeah, the aldehydes, like ketones, carboxylic acids,
Carboxylic acids. Yeah. So we're gonna start with these 3 first.
and alcohols.
Oh, and alcohols, yeah, including Black Label alcohols. It is an alcoholic beverage.
Yeah, it's an alcoholic beverage.
So, alkanes, if you have a chain like this, right, the carbons are single bonded to like either 3 or 4 hydrogens. So if it's just one monomer like this, then it's carbon tied to 4 hydrogens, right? Alkenes would have a double bond, so they would be carbon-carbon double bonded, and then the other 2 bonds that the carbons have, instead of having them with the hydrogens, the carbons, they bond with each other to create a double bond, and then the hydrogens are freed up, right? But this one is quite reactive, so it's quite quick to move from being a double bonded hydrocarbon to being a single bonded hydrocarbon. So it's reactive. We say it's reactive. Right? And then alkynes have triple bonds. Triple bonds. Right. So they're called bonds. They're called triple bonds. One, because the way in which they bond depends on the chemical nature of carbon. Now, carbon and hydrogen, they tend to form covalent bonds between the atoms, right? So here we get covalent bonds forming, so that we have all of these monomers and polymers and stuff. But then triple bonds would be one carbon, 1, 2, 3. So that means 3 of these. So these ones would only be bonded. The carbons would be free to bond with just one hydrogen each, and 3 of the bonds would be with each carbon. Now, if this is a monomer of a triple bonded alkyne, then it's even more reactive than the alkene and the alkane. Okay, and then aldehydes, what is their special property? Oh, they have a bond that's called, they have a
oxygen bonded to one carbon.
Just, is it Cu or
CHO.
CHO? Okay, cool.
So like the oxygen is double bonded to the carbon.
Yeah, so you'd have your chain there, and then you'd have carbon double bonded to oxygen and then a hydrogen. Yeah, so you'd have, let's say you have another carbon there. Then if it is a aldehyde, you'll have this functional group there. And then alcohols would typically have an OH. So they have an OH, so it's oxygen and hydrogen. It's called a hydroxyl group. And that you would find if you have, let's say, methanol, for example, or ethanol. It would be 2 of these, and then there's an oxygen, and then there's a hydrogen. Wait, and then where's the other? Wait, let me see the alcohol. Oh, okay. Right. So then the carbon would then tie up with, I just want to see if it's when it's a, oh, okay, cool. So, okay, so where the sticks end, just imagine those to be hydrogen atoms, right? Tell me we're left with 15 minutes. Oh, you just rejoined. All right, so, yeah, so now in order for us to answer the first question here, multiple choice number 1.1, we need to first recall what the general formula for an alkyne is. Now, but before I get into the aldehydes and whatnot, there's a certain formula for the ratio of carbon to hydrogen atoms that's usually given for each of these 3. So I'll just make alkanes blue so we can write the formula there. I'll make alkenes green, then we're gonna write the formula somewhere there. I'll make alkynes yellow, and then we're gonna write the formula somewhere there. Alright, now back to black. So we've got the number of carbons and the number of hydrogens in each of these 2. So generally, in all the cases, right, when we discuss any hydrocarbon or monomer or polymer that ends with the suffix anes, A-N-E-S, that ends with this suffix here. When we work with that kind of monomer or polymer, usually when you have the number of carbons, the number of hydrogens become, it's 1, 2, 3, 4. Kenja, what is it? It's
For what? Alkenes.
for alkanes, yeah. The formula is 2n plus 2.
You get an extra 2. So it's the number of carbon. So
Okay, let me
2
do this.
times the number of carbons plus 2.
Plus 2. Yeah, so check this out. For every number of carbons you have in an alkane, strictly an alkane, for any number of carbon atoms you have, then you have 2n plus 2 hydrogen atoms, right? So we can even do it just this one alone. We've got one carbon here, 1. So if we take 1, we multiply it by 2, we'll get 1, 2, that's the 2n, and then we add 2. So C1 will be H4. C2 would be 2 times 2, it's 4 plus 2, it's 6. So it'd be C2H6. And the pattern increases like that. So that's how you get methane, ethane, butane, propane.
Yeah.
So the gas is methane, you know methane, right? CH4. This is the basic structure of it. So from it, you get a polymer. When you increase the number of carbons, you get ethane, which is another denser gas than methane. Then you increase the number of carbons, you get butane. Is it propane first?
Yeah, it's propane.
Propane. Then you increase the number of carbons, you get butane. And then you increase the number of carbons, you get pentane. You get 6, you get what? Hexane. 7, you get septane
Or heptane.
or heptane. 8, you get octane, etc. So those are just the ones that end with ane, right? Now if you're going to have the alkenes, which end with ene,
Dectane, 14.
then the numbering, the naming still works the same. But for every number of carbon atoms you have, the relationship between the number of carbon atoms and the hydrogen atom changes, because in this case you have 2 carbons and 4 hydrogens. So then that relationship is, for every number of carbons that I have 2 hydrogens in my hydrocarbon. So the configuration of hydrogen and carbon atoms like this, they're called hydrocarbons. And then the different types of hydrocarbons we have. The first one we talked about is ethane, methane, so those are alkanes. Now the second ones we're talking about are alkenes. So this one is ethene. So it's the second one, so 2 C's mean ethene. 1 C means methane, but I don't think we have methane because...
Alkane, 1 bond. Alkene, 2 bonds.
2 bonds.
Alkyne, 3 bonds.
Oh yeah, even with your fingers. So Joy just did this cool thing, right? So you look at any of your hands, and we know that for alkanes it's a single bond, so you can just raise 1 finger for alkane. You know that for alkenes it's 2. Okay, then for alkenes it's 2 bonds, so it's 2 fingers. And alkynes, it's 3 bonds, so 3 fingers. Right. So we've just discussed alkanes, alkenes. Now we're going to discuss alkynes. So now alkynes, whenever we have a certain number of carbon atoms, then the corresponding number of hydrogen atoms is the same as
It's not the same.
as what?
You subtract 2 because you have 3 bonds
Yes.
connected to each carbon.
Yes.
Therefore, you're gonna have 2 hydrogens
Okay.
for 2 carbons.
So then I'll have 2n. So if I have 2 carbons, then I'll have 2 times hydrogen minus 2.
Got it. It's going to be 2 times 2 is 4.
Uh-huh.
And then they both have triple bonds.
Okay.
So you're gonna have to subtract the 2.
Okay, that makes a lot of sense. So we can do it like that. So with alkynes, then the relationship between the number of hydrogens and number of carbons is a little bit different. And how is it different? So for every number of carbon atoms, you have n. Then the
Is that
number.
how you write expression for hydrogen?
How you? Is that how I write what? Yo, I'm being bullied. Yeah, yo.
No, it's because I keep on telling you. Write your letters legibly. Make
No.
sure it's visible. That looks like an N.
Okay, but it did look nice. But these ones are visible, right? Okay, cool. So 2n minus 2. So in other words, here, for every 2 carbon atoms, we have 2 times n, which is 2 times 2 is 4, minus 2. Then that gives us the corresponding number of hydrogens. Now, if we're going to guess for number 1.1, for alkynes, we've got CnH2n. Doesn't look like it's correct because that's for alkenes. So we can eliminate that one from our selection. Then the second option is C2n, H2n, and I don't think that exists.
It doesn't.
So we eliminate it. C looks very correct. N is for alkanes, so it's also incorrect. So C is the correct answer. Then
Oh, I know this one.
Then number 1.2. Right, so the type of reaction that takes place when a carboxylic acid and an alcohol react in the presence of an acid is called esterification. Because, okay, here's something we must know, ne? In our learning guide, something that's called esterification. An ester is formed when an alcohol reacts with a carboxylic acid. Esters contain a carbonyl functional group as well as an oxygen atom bonded to the carbonyl atom and another carbon atom. So just this part of the definition, an ester is formed when an alcohol reacts with a carboxylic acid in the presence of, I guess, an acid, right? That gives us, right, so I'm going to give you reasons why the other 3 options are incorrect. Addition, that's not really a chemical reaction. It is. Oh, okay. My mistake. What happens in addition?
In addition, unsaturated compounds undergo addition reactions to form saturated compounds. So you add certain compounds in order to form. You add as a compound to an unsaturated compound to form a saturated compound.
Alright, cool. So, okay, so with hydrocarbons, the more bonds you have between the carbons, the less saturated the hydrocarbon is. So, now we're going back to our alkanes, alkynes discussion. The alkanes are typically saturated hydrocarbons. Alkenes, not saturated. Alkynes, even more unsaturated. So when you add through the process of addition chemical or rather atoms to an alkyne molecule or an alkene molecule, when you add atoms to those bonds, then you do what you call addition. And it's
called
the
hydrohalogenation. You're adding a halogen to the compound.
oh, so okay, I see. So okay, hydrohalogenation is adding a hydrogen, like a
hydrohalogen.
yeah, like a chemical compound that has hydrogen and a halide to an alkane. Right. So unsaturated compounds can undergo an addition reaction to form saturated compound. So when it's saturated, it's not easy for it to react. That's why it's called saturated. So addition is the process where you add some chemical compounds to unsaturated compounds so that those unsaturated compounds can be saturated. So that's why addition is not correct. Hydrolysis is adding water to a chemical reaction. So that also doesn't fit. Substitution. Do we have substitution in chemistry? What's a substitution reaction?
Substitution involves replacing an atom or a group of atoms with another atom or a group of atoms.
Okay.
Two types of saturated structures can be interconverted by substitution.
Oh,
it doesn't
okay.
really tell us what it is, but
yeah, it just means like if you have a hydrocarbon like this, right? Let's say C. It just means if you have a hydrocarbon, let's say it's a long ass chain.
Yeah, so we have hydrolysis somewhere in chemistry, but it's not
But
here.
it's not in organic chemistry, yes, I know. So bless you. So let's say you have a polymer like this, it stretches, right? If we want to add, then let's say we want to make this one a saturated compound, then we will add either a compound or an atom. That's addition. Hydrolysis would be adding water, and then what would be the net effect?
I don't know. Do I have? I don't have
Hydrolysis, but it's a kind of chemical reaction that happens in inorganic chemistry. So not inorganic chemistry, in inorganic chemistry. Ish, yeah. So let me rather say hydrolysis is a chemical reaction that happens outside of organic chemistry, whereas addition, substitution, and esterification happen inside of organic chemistry. Yeah, let me use inside and outside, because in and inorganic confuser.
Hydrolysis happens when salt dissolves in water. Sometimes changing.
When salt dissolves in water, yes.
It's found.
So it's like a breaking down.
Yes.
Like a ionization type thing.
Yeah, it changes the pH of a solution.
Yeah.
It's found in acids and bases.
So in acid-base reactions, that's what you typically find. So inorganic chemistry, that's the branch of chemistry where you find the reaction of hydrolysis. And then substitution, let's say you want to change this H to another chemical, maybe bromine or chlorine or iodine or fluoride. You see? So let's say you want to change this, then you can substitute using the chemical reaction of substitution, so that instead of an H there you have a Br or a Cl or an I or an F. That's called substitution. My bad. Now esterification is another thing, and by definition what we know is that it is the reaction formed when an alcohol reacts with a carboxylic acid. Right, so in this case, the correct answer would be number D, esterification. And one of my neighbors' name is Esther, so if she heard us talk about esterification, I wonder how she would feel. So now 1.3, we're told about isomers, right? Now, Nobutle, so when we have methane, remember methane is CH4, right? Methane is CH4, and its structural formula looks like this, where at the ends of the sticks there is H for the hydrogen. Now, if we saturate this monomer with other monomers that increase the structure of this. So let's say we move from it being just methane to it being ethane. Now let's say we move from it being ethane to it being propane. It's the third one, right? And then let's say we move to it being butane, which is the fourth one. Let's say we stop at butane, right? So just imagine these are hydrogens. Hydrogens, right? I think the more carbons you have, the more of a string you have, the denser the material is. Because if you compare methanol to, which is methylated spirits, to even straw rum, you can tell which one vaporizes quick, right? Yeah?
Yes.
Yeah, so methylated spirits turns into gas. So that means it's probable that it's hydrocarbons before being reacted to form things like methanol, etc. Then it must be less dense the smaller the number of carbon atoms are. And the more the number of carbon atoms are, the more dense it is, the higher the boiling point, etc. and stuff like that change. So now that we've looked at different, like as the chain of the hydrocarbons increase and the density changing, we're gonna write down these as chemical formulas. So instead of writing them, what do you call this type of formula? Condensed structural. Yeah, this is structural. Then condensed structural would be C. This is structural. Structural. Then condensed would be CH3, CH2, say 1, 2, ne? And then another CH3, right? So what this part here, CH2, say 2, means that you have the first CH2 and the second CH2. And then here you have the CH3 and the other CH3. So this here is condensed and this here is structural. Then the chemical formula would be C4H 1, 2, 3, 4, 8, 10. So this would be the chemical formula, right?
No, that's the molecular formula.
That's the molecular formula. Okay. Molecular. So molecular form, condensed structural form, and structural form. Right, so in this case, we've got a CH3, CH2, 1, 2, 3, 4, and a CH3. So it's 1, 2, 3, 4, 5, 6. So this is hexane. First one is hexane.
But it could be branched.
Sorry,
Oh, it could be branched, yeah. Yeah? Hello? Call ended, yeah. Let's do this. Turn the home screen. New meeting. update these guys. Shite. Turn the home screen, start instant meeting. You know, I just need a bit more tech, then I'll really work like Tony Stark. Like there's this thing called a freestyle that I saw. It's like, it's shaped like a surveillance camera, right? So you can put it like this and it projects there. You can put it like that and it projects there. Yeah, so I want, like on this one, you can, on this computer, you can have like,
Should I to help me then?
I think so. I'm disconnected.
I like her so much.
Yo, I just want to see, what's the code? It's UBV dash MRHK dash UPD.
Hey, Betty, open up.
Yo, one of them is gonna make a noise. I'll just make this one. Gotcha.
Welcome. Which advertisement was that one for?
Oh, I'm not sure. But it sounds familiar.
Yeah,
That's
these
the
are
thing.
what
Eh?
it's available slide 6.
Who's standard 6?
Slide
Oh, slide 6.
or Jamboard.
Oh. I know, it's weird. It's weird.
Why didn't you say C3H10?
C3H10.
Why?
For this one that I drew down here.
Yeah, in the molecular form.
Why didn't we say C3H10?
Where's the fourth carbon?
The fourth carbon. So remember, these are all the same expressions of the same thing, right?
Just came for here.
Or why didn't I have C4 here?
Or is it because the one in brackets is that? I don't want to say squared, but
It's
yeah,
like it
sounds
repeats twice.
Yeah. Okay.
So there's the
that's
first time, there's the second time. So the one is for the first time, the other two is for the second time. So
okay.
CH2 just represents these three atoms, and then times 2 meaning for this block here. And then CH3 would refer to these 3 there. CH3, these 3 there.
Okay.
I like how this thing leaves a tail like a comet. And it's blue on the screen. But on this
It's
tablet,
green.
it's
Green.
green.
It's green.
How do I
Mine
change
is
its
red,
color?
but it appears another color for you guys. Oh,
Yes.
no.
Yours, it appears pink.
Pinkish, purplish, yeah.
Oh, you know why?
Why?
Because the color has a round thing in my bulb name.
Oh,
When I use it, color is
mine is
yours.
red. You see,
But like,
see
When
when
I
I
watch
edit, it shows my screen as red.
I don't get it, but okay.
no.
I think
I
it
don't know
corresponds
how
to
see
our
the color of
login color. You see there next to your camera where you're logged in.
Yeah.
You can see
Your
Mr.
color.
P's one. His is green. Yours is pink.
Oh, this is green, the
Yes.
circle.
Oh.
Yeah, so your circle is pink. So when you circle it, it
shows the
projects
color
the color
corresponding to
Yeah.
my color.
Okay.
That's
You know,
really cool.
to the way bots of stuff.
That's so cool though. So yeah, let's see. So we've got multiple hydrocarbons. The first one has 1, 2, 3, 4, 5, 6 carbons. The second one also has 2. 1, 2, 3, 4,
In
5,
total.
6. They all have 6. They all have 6 carbons.
Yeah.
They all have 6 carbons. It's just they have different arrangements of the chemicals, of the atoms. Ooh, this one is a bit challenging?
It's just that it's hard to actually picture what it looks like when it's in condensed.
Is that 2.1?
1.3, yes. Wait, are you talking
Okay.
to us?
She's not talking to us.
No, okay, she's not talking to us.
Why are we here?
Okay, I was looking at other questions that follow. Because after this one, your organic chemistry, it's inorganic, redox reactions, and then acid-base reactions, half reactions, catalysis, and then yes. So let's finish this one, number 1.3. This one is a bit tricky because each of the condensed isomers, or rather these isomers, has got 6 carbons. So it's not easy to just say 6 carbons, therefore this, therefore that. So you have to think a bit more. Do you think it will help, Joe, if we drew the structural formulas?
It will help me actually understand already what kind of a structure is.
Okay. So we can.
They're isomers, so they're all going to have like the same molecular formula, if I'm not
Like structure.
mistaken.
Yes. So the first one would be CH3.
I think this is a chain isomer.
1, 2, 3, 4, 5, 6. So that's the first one. The second one would be C123, C12.
So must
Then-
be careful of these ones, just CH3.
Yeah, because it has
It could be like
a double bond somewhere
no,
as well.
or even a chain.
Yes, check this.
Okay.
What I'm seeing is, so there's 2.
You see, say like this one. That's a branch.
Yes, that's what I want to do, like this, right?
嗯
1, 2, 3, 1, 2, 3, and then the last C, 1, 2, 3.
Help.
Did we kick you? Oh, screen share.
No, I'm here.
Oh, okay. You were doodling. I thought maybe the call
It's a call
dismissed
for
us.
help.
Oh no, I just wrote B.
Oh, okay.
Oh,
So
she's writing that the answer is B.
answers B.
Are you saying the answer is B?
Yeah, that's my wild guess.
That's a wild guess. That's fine. That's the second one. The third one would be C123, and then C. Then it has a H, and like that, right? Then a C12, then another C12, then another C123. And the fourth one would be C123, C12, C123, then a C12, and then a C123. So now we have to determine which one has the lowest boiling point. What's the one thing that determines the physical properties of
Surface area.
surface area?
Van
Okay.
der Waal. The Van der Waals forces, intermolecular forces.
Okay.
The one that has stronger intermolecular forces.
So check this out. The melting points and boiling points of hydrocarbons increase as their number of carbon atoms increase?
Oh, but it's not telling us which one. It's both melting point and boiling point.
It's fine. So we just have to then guess which one has the lowest boiling point. But now, they all have the same number of carbon atoms.
So it's about surface area.
The number of carbon atoms increases. Can we look at it again?
Okay, so I made the sketches of the different options. So the blue one would be the first option. Option A. Let me just... So at the end of these sticks, just imagine a hydrogen atom, for simplicity's sake. So there's the second one. And then the third one.
Option B is the only one with more carbon.
No, they all have the same number of carbon atoms. I think the answer is also in the definition of that, the description there, that melting points and boiling points increase
But,
as number of carbons increase.
but what about the carbons that are not in the straight chains, but the bonds have broken out?
Like they're branched out. I think that's a good observation because I was gonna get to that. And Joy also mentioned something important to say.
Yeah, it says straight chain molecules have higher melting point and boiling point than branched chain molecules.
So it's
with
saying
the same number of carbon atoms. Yeah.
So you're saying
Okay.
Straight chain.
Straight chain
Yeah.
have higher melting points
and boiling point.
and boiling points.
So therefore, the longer the carbon chain,
The higher the melting and
yeah.
okay, because so then it goes back to what I was
The
thinking.
carbon chain, the higher the melting point. So
Yes.
D would be like at a higher melting point than the other three.
So let's put it like this: the blue one is A,
Yes.
the green one is B,
Okay.
the yellow one is C, and the red one is D. So which one has the longest chain? I think let's start there.
No, A.
B has the longest chain, right? So it should have the highest melting point.
How do you say B has the longest chain?
No, I
When
mean,
the straight chain carbon atoms is just 4.
yeah, that's what I meant. I meant A, sorry, not B. So the longest chain of carbon atoms is A.
A, yes.
Yes. And the description there is that longer chains have higher melting and boiling points than branched out chains, correct?
Yeah.
So basically, it's about the surface area.
The surface area, okay.
So it means the larger the surface area, the higher the boiling point. And the lower the surface area, the lower the boiling point.
So in other words, the choices we have now are between B, C, and D. Because we must find the one with the lowest boiling point or melting point or something like that.
And it's B.
Yes, you are right.
So the one with the lowest boiling point would be B. Because the surface area is less. The chain is the shortest.
Yes, it has many branches as well.
And it has many. Also with more branches, then lower boiling point as well.
I think we can.
Okay, I can work with that. Let's just quickly look at the answer guide.
Yay, Nobutla, you got it right.
You've got it right. Well done. Yeah, it's C, D,
Yay.
and B. So that's everything. Okay, so that's enough for organic chemistry multiple choice. We're gonna go to question 2. The letters A to E in the table below represent 6 organic compounds. All right. The other one is a branched out hydrocarbon. The other one has got a hydroxyl group. Other one is butane 1-ol, butane 2-1. Write down a letter that represents each of the following. A tertiary alcohol. What's a tertiary alcohol again?
Tertiary alcohol is like the one that has like
Hydrocarbons on hydrocarbons branching from the carbon that has the OH group.
So A.
No. We have to. So here it's no longer multiple choice. We're not longer doing multiple choice. But what?
We must write the letter. So
Yes.
in what you guys are explaining, it looks like it falls under A.
Before
No.
we say it's definite.
Why don't you say what do we regard as an organic group?
Organic group. That's an interesting question.
Because here they said R is an organic group.
So that would be R could be a chain of hydrocarbons.
Okay. So here a tertiary is when it's like
hydrocarbon, then hydroxyl group. So now we should think of it this way, right?
So it could be like methane, OH.
Yeah, it could be having a methane there branching, a methane there branching, and a methane there branching, and then OH here. Yes. Yeah. So remember methane, right? Can you see on the Jamboard, Noble?
Yes.
So it's an alkane because its suffix is ane, right? Now its alcohol form is methanol. That's methylated spirits, right? And how it looks at the end, instead of a hydrogen there, it's got an OH. This is called a hydroxyl group.
Yeah.
Hi. Hydroxyl group. Alright? So now, if you want to go to secondary alcohol, then two of these hydrogens you can replace with
this is a tertiary
methanol, like a methyl.
Proper 2-ol.
Oh, okay, we'll discuss that. I just want to explain this, right?
Yeah.
So, Nobuto, when we take out two hydrogens, and in their place we put in other hydrocarbons, right? We substitute them there. Then we're moving into a secondary alcohol. And if we do that with 3 and replace 3 hydrogen atoms,
She left.
that's the Jamboard.
Let me refresh.
Okay. Alright, so if we take the hydrocarbon isomer, this is an isomer. If we take this and we replace each of these H's. What, watching?
You should have seen it. No, it was just like
Oh. So when we do that, then we move into a tertiary alcohol, right? But in alcohol, we see it with this thing here. So it'll be your hydrocarbons, and then if it has an OH, then we know it's hydroxyl group, then we know it's an alcohol. So now our question is, a tertiary alcohol.
I have so many beagles here.
Tertiary alcohol.
But I think that's primary.
That's maybe secondary. Or maybe primary.
Yeah, it's secondary. I think secondary then. No.
Okay. A tertiary alcohol.
There's an OH here on E.
On E, there's no OH.
There it is.
Oh, here it is. Here it is. But I don't think we've got enough branches on. Hold up.
Wait.
So let's investigate, right? Let's investigate. Okay. Let's go to 110. Oh, no. We are here.
210. Oh.
Yes. So I want to open up alcohol, methanol, methanoic.
100.
I just want to get to the part that speaks about alcohols. The alcohols, yay. So alcohol is an organic compound with a hydroxyl functional group, is bound to a carbon atom. General formula is that. Alright, so on page 120 of learning guide, so you can just type 131 on the search bar. That's the discussion on alcohols. So we're going to investigate there why, we're going to investigate why, we have different rules for tertiary and primary and secondary alcohols. Alright, cool. So there can be a functional group attached to these different types of carbon atoms. There are three possible types of carbon atoms for a alcohol. A primary carbon atom is attached to only one other carbon atom. So I think that's important to note. So primary carbon atom is attached to one other only one other carbon atom. Then secondary is attached to two others, and tertiary would be three other carbon atoms. So that means in our question, or rather this question, we might have to look at a primary, which one we could say is our primary carbon atom in the structural organic compounds that we see. And we might also need to sketch C and D just so we can see where we put like butane 2,1 and butane 1-ol, where do we put those? And in terms of are the alcohols, primary carbons, secondary carbons, etc. Okay, so here there can be a functional group attached to these different types of carbons. When a hydroxyl functional group is attached to a primary carbon atom, it's called a primary alcohol. For secondary alcohol, the hydroxyl group is bonded to a secondary carbon atom. When a hydroxyl group is bonded to a tertiary carbon atom, then it is a tertiary alcohol. So
So can we say the more branches you have in an alcohol, then it's the more you can classify it as a tertiary alcohol. looking at these structures?
I would say no.
Okay.
Because, can you see my screen? No.
Yes, I'm looking at organic molecular structures.
Yes, awesome. So on page 121 there, you see the primary alcohol is bonded to a carbon atom, or the hydroxyl group rather, the OH, oxygen and hydrogen there at the side on the right of this four carbon hydrocarbon. The OH, to make it an alcohol, is bonded to one carbon atom.
Mm.
So that makes it a primary alcohol.
Mm.
The second drawing, the OH group is bonded to a carbon atom that is bonded to two other carbon atoms. So in other words, where the OH is, sits on a carbon atom, and that carbon atom is bonded to two carbon atoms on the side.
Okay.
Now, tertiary alcohol would be when the hydroxyl is bonded to a carbon atom, but that carbon atom that's bonded to the hydroxyl is also bonded to three carbon atoms. So, in other words,
Oh,
you get it.
you're just reading there.
Well, I'm just describing the picture
Yeah.
there, but I guess it's
Yeah,
also
I get
said
it
in
as
the
well.
thing, yeah. So let's think about it this way. I'm just gonna draw a sketch.
It makes sense. So the hydroxyl, the carbon that the hydroxyl is bonded to must be bonded to three other carbons.
Yes, for it to be a tertiary alcohol.
Okay.
But if it's a secondary alcohol, the hydroxyl OH must only be bonded to a carbon atom that bonds to two other carbon atoms.
Okay.
And if it's a primary alcohol, then the OH group is just bonded to one carbon atom, and that one carbon atom in the hydrocarbon is linked to one other carbon in the
The secondary alcohol just explains itself.
and tertiary, I guess. So you've got ethanol, and then if you've got, let's say, propanol.
Open the question paper.
Oh, okay. The question paper looks like that. All right. So the first letter A.
Yay! Nobody is on fire today.
Hey, Nobuki is a science girl. Hey,
Hey.
Nobuki is our science girl.
Yay!
So the first, the hydroxyl group OH is bonded to a carbon that's bonded to 1, 2, 3 carbons. So yeah, 2.1.1 would be the tertiary alcohol. So Nobuki, that's the answer you gave, ne?
I did from what she read in the beginning when she was explaining what a tertiary alcohol is.
In the beginning. Hey. Alright,
Now
so
that I've broken it down, I actually know what it means.
so alright.
So E is a secondary alcohol.
Alright. It's nice when you know these definitions and you can visualize them, yeah. So tertiary alcohol would be A, 2.1.2, an aldehyde. Aldehyde. Let's look at properties of aldehydes.
So you didn't even give us a chance to see, or maybe while you're explaining what an aldehyde is, we get an image.
Oh, okay. So I must leave.
Yeah.
So I must leave the question,
Yeah.
and then.
And then we must, analyze the question and see, okay, which one could be the answer. And
All right.
Then go explain. And then come back, and then Nobuki and I will give the right answer.
Give the right answer.
I can
No, it's fine. It's your class. I cannot stop you from customizing the experience. It's your class.
Yeah.
Okay.
We just wanted to pick. I just wanted to have a view
Of what these look
what
like,
these look like,
so that when we go through the definition,
I can get the
we
answer.
understand. Alright, cool. Now let's do that. Let's do that. You guys are my commanders as your class. So, alright. let's look for the question wanted an aldehyde, right? So we must look at these 5 and choose which one is an aldehyde.
We're looking for chu.
For chu.
Soaking alcohol.
So aldehyde king. Alright, yeah, let's check that out. Joy, let's look in your textbook and then we'll also look.
It's like a hydrogen atom is bonded to the carbonyl group. So
Okay.
that's all it says.
Oh, yeah.
Alright.
It gives us the
Like a
It's
general
a giveaway
question.
with those double bonds.
yeah. So
Okay.
so like we know the answer.
Yeah,
We do. So like second, just explain so that it like
It makes sense.
yeah,
Yeah.
it's just
Okay, so
hammering
what?
the information.
So what,
into
the answer
it.
is B?
Yes, the answer is B.
Answer is B. And that's because with B, an aldehyde would have a double bond to an oxygen, 1 bond to a carbon, and 1 bond to a hydrogen. And a ketone, instead of the hydrogen, then you'd have a carbon and a recurring chain. But carbonyl group is the larger body containing both aldehydes and ketones, whereas aldehydes would have, let's look at their properties. They have the same general formula, but I just want to find a way to distinguish the two. What is the suffix for ketones?
Al.
Al.
Oh, ketones.
Yeah,
1.
just 1.
On. Like
Oh,
on.
on, ne?
Yeah, like 1.
Also, like this one would be a ketone. Ikai ela. Butane 2 on. That would be a ketone. And this would be a aldehyde. Alright, cool.
OL.
Al is a suffix for aldehyde, yeah.
Yes. OL is for alcohol.
OL is for alcohol. So methanol, ethanol, propanol. If you look at your can of air freshener or deodorant, you'll see they all end with propanol, 2-butanol. They've got all there, like. So those are alcohols. But not the kind you get drunk on. No, that's dangerous.
Yeah, but those things will eat you up on the inside.
Did you see the warning sign here for methanol?
Corrosive.
I saw it's a toxic.
Methanol is toxic.
The trickiness have to know this.
So that's why, like, when you drink something that you're not supposed to drink, that's why you foam in your mouth.
It's a
Because I saw this other meme on Facebook, Marabang wants to so they're like, you see, Rona, we started with what is that sachet we used to make cool drink with? Sweet 8, Cool 8,
Date.
Drinko Pop. We started with Drinko Pop, then Raya was Sigzo, Sweeto, Foro, and then we jumped to Savannah. That's why we're not aging as quick. Tafune like that at last. So.
Look, guys, it's starting to rain hard.
Is it raining?
And I'm
Oh, okay. But anyway, we're almost finished.
Yeah. Rain when I'm at home.
The other day you left and it took so long before it rained.
When I got there, it rained.
It was raining at your place.
Yeah. Like when I got off the taxi, it started like.
Like a heavy pour
How many
or is this
hydrogens were there?
How many what?
How many what?
Hydrogen.
Oh, for the